Hello and welcome to the second lecture for Intro to Logic, Unit 3. Sorry my microphone is a bit quiet. I try to adjust it afterwards, but it doesn't work that well, so we'll muddle through. Today we're talking more about translating into predicate logic and focusing in particular on monadic predicate logic, that is, predicates that just apply to one thing. Sometimes you have more than two of them in a statement, so we looked at last time the square of opposition. So when you have two predicates, you can have universal affirmative, all f through g's, for all x, fx, arrow, gx. The opposite of that, the far side, kitty corner to it, in the square of opposition is a particular negative. Some f's are not g's. There is an x, fx, and not gx. We also have universal negatives, no f's or g's, for all x, fx, arrow, not gx. The real opposite of that is a particular affirmative. There is an x, fx, and gx, which is some f's or g's. Those are pretty normal forms that you use a lot. But we can have more complicated forms when you've got more than two predicates. Suppose we're saying every rock star is popular and sexy. We want to say every rock star is popular and sexy, so we want to combine together the px and the sx into the right side of the arrow. For all x, if x is a rock star, rx, arrow, x is popular, px, and x is sexy inside a further set of parentheses. Something similar happens when you have adjectives modifying nouns. So if you have all popular rock stars are sexy, that means for all x, if x is a popular rock star, which means that x is both popular and a rock star, then x is sexy. For all x, if in parentheses px and rx, x is popular and x is a rock star, then sx, x is sexy. So anytime you have an adjective modifying a noun, you want to join together both the two predicates applied to the same variable inside a further set of parentheses. Some carrots are orange vegetables. This is a sum statement, so we use the backward z. There is an x is a carrot, and in parentheses, x is orange, ox, and x is a vegetable, vx. You want to keep complex predicates together like that when they're joined together inside parentheses, applied to the same variable. You want to keep them together inside the parentheses, even when there's a negation involved, you don't break them up. So if I want to say no hamsters are endangered animals, you want to say either there don't exist hamsters that are endangered animals. So it's not true that there is an x where x is a hamster and x is endangered and x is an animal. Or you want to say for all hamsters, for all x, if x is a hamster, then it's not true that x is both endangered and an animal, ex and ax. So the not stays outside the parentheses in that second example. Some intelligent students are not pathetic geeks. Here we've got an adjective modifying a noun in both the grammatical subject and the grammatical predicate. So both cases, both sides of the statement are going to be joined together inside further parentheses with ands. So we say there is an x is intelligent, and x is a student, and it's not true, since they're not pathetic geeks, it's not true that x is both pathetic and x is a geek. So again, we keep the not outside the parentheses over there on the right, even though we've got not applied to pathetic, it's applied to both pathetic and geek, so we keep it together like that. Notice that when you have certain other constructions that look like adjectives modifying a noun are not really the same thing. So a computer programmer, for example, is not someone who's a computer and a programmer. That's someone who programs computers. A basketball player isn't someone who's a basketball and a player. I always like that example. I always think about a basketball running around being all smooth, hitting on people at nightclubs. You're a player, basketball. No, that's not what a basketball player is. It's not someone who's a basketball and a player. So someone like a computer programmer or basketball player, we wouldn't use two different predicates. We would just use one predicate for the whole thing. Sometimes we combine predicates with or rather than and. Usually that's when there's actually an or in the English wording. Anything that's plaid or striped is ugly. For all x, if x is plaid or striped, in parentheses px or sx, then x is ugly. All athletes are either quick or strong. For all x, if x is an athlete, then either, in parentheses, qx or sx, x is quick or x is strong. And we have negations. Usually, again, you keep the negations outside the further set of parentheses. So if I say some professors are not either quick or strong, there is an x is a professor, and it's not true that either x is quick or x is strong. Again, you have the not outside the parentheses there. There's a very rare circumstance in which the English wording uses the word and, but one way of translating it uses the word or instead. So consider the sentence, all doctors and lawyers are rich. right? So you don't want to word that as for all x, dx and lx arrow rx. That would mean for every value of the variable, if x is both a doctor and a lawyer, so for every particular individual, if x is both a doctor and a lawyer, then x is rich. Yes, there are a few people in the world who both went to med school and to law school and became doctors and lawyers at the same time, and I'm pretty sure all those people are rich, but that's not what the statement is about. It's not just about the people who are both doctors and lawyers at the same time. So one way of translating this is by saying this: for every value of x, if x is a doctor or x is a lawyer, then x is rich. So we use an or rather than an and in the logic to fully capture what the statement is trying to say. Now, there's another way of translating that does use an and. That's where the and comes from in English. So you might say, for every value of x, if x is a doctor, then x is rich. And separate from that, for every value of x, if x is a lawyer, then x is rich. So that's where the and comes from in English. Next, we're going to talk about a few other quantifiers that we haven't talked about so far. One is the word only. So what does it mean to say only A's or B's? So the way the book does it, it thinks of only A's as B's as no non-A's or B's. So if you say only cats purr, it would translate that as either for all non-cats don't purr. So for all x, if you're not a cat, then you don't purr. Or there don't exist things that purr that aren't cats. So it's not true that there is a value of x where x purrs and x is not a cat. I like to think of or a different way. I like to think of it as the converse of all. Now this is equivalent, so you can do it either way. You can think of it as the converse of all. It just reverses the direction. Just like only if reverses the direction of if, only reverses the direction of all. So if I say only A's or B's, that's the same as saying all B's are A's. So if I say only cats purr, all the things that purr are cats. For every value of x, if x purrs, then x is a cat. But don't translate it as for all x, if x is a cat, then x purrs. It's not the same as all. You've got to reverse the direction. Unfortunately, only can create ambiguities when you have adjectives modifying nouns. So if I say only happy cats purr, that could mean one of two things in English. It's not actually straightforward. It's ambiguous in English. Before you can translate it into logic, you've got to remove that ambiguity. So it might be read as just being about cats. So the only cats that purr are the happy ones. So you might say either this: if you're a cat that purrs, for all x, if you're cx and px, then you're happy. Or you might read it as this: there don't exist an x where x is a cat that purrs, it isn't happy. Or you might say, for all x, if you're a cat, then if you're not happy, you don't purr. Or you might read it as say, if you're a cat, then if you purr, you must be happy. I like to do it that first way. For all x, if you're cx and px, if you're a purring cat, you must be happy. But there's another way of reading the sentence, only happy cats purr, where it could be about, you're talking about everything in the world. The only thing that purrs at all are happy cats. So among everything in the world, the things that purr are all happy cats. Then you would say, for all x, if you purr, px, then you're a happy cat, hx and cx. Or you'd say, if you're not a happy cat, you don't purr. For all x, if not hx and cx, then not px. Or you could say there don't exist purring things that aren't happy cats. So it's not true that there is an x where x purrs, and it's not true that x is a happy cat. So it's not true that hx and cx. One thing that's even more annoying is not only is only ambiguous, but the phrase the only does not mean the same as only. In fact, the only converses it back. So only A or B means the same as the only B or A. If I say only philosophers are likable teachers, that's the same thing as saying the only likable teachers are philosophers. So it reverses the direction back. So if I were translating the only, I would think of the only as the same as all. So I'd say for all x, if x is a likable teacher, lx and tx, then x is a philosopher, px. Or I might say, if you're not a philosopher, you're not a likable teacher. So for all x, if not px, then not, in parentheses, lx and tx. Or you can say there don't exist non-philosophers that are likable teachers. So it's not true that there is an x where not px and not px and lx and tx. So because only is the converse of all, and the only is the converse of only, all and the only end up meaning the same thing. There is a slight difference in emphasis. Usually if you say the only, you're suggesting that there aren't very many of the things in the category. But logically speaking, it's like the difference between and but. We treat them exactly the same. Next, we're going to talk about the word the. When you use the word the without only, that's actually can mean a couple different things in different contexts. So you've got to use some common sense to think about what it means in that context. So in some cases, when you use the word only, you're talking about a specific thing. And rather than using a quantifier, you just use a letter at the beginning of the alphabet to stand for that particular thing. So if I say the dog ran away, there's some particular dog that I'm talking about, right? That dog has a name. You could call that dog Fido or Rex. So the dog here is just a name of the dog. So if I say the dog ran away, I would just write that as RD, where D is the name of the dog. But if I say something like the dolphin is a mammal, you're talking about every member of the group of dolphins. So this really means the same as all dolphins are mammals. So you would say for all X, if X is a dolphin, then X is a mammal. In English, sometimes we leave quantifier words off. We don't use a word like all or only or some. And we leave it to the audience to figure out what we mean. So oftentimes these sentences are ambiguous, but you have to sort of know from context what the person means. So I just say frogs are amphibians. I don't say all frogs are amphibians or some frogs are amphibians. You have to guess what I mean, but I probably mean all frogs are amphibians. So I'm talking about the entire group of frogs. So I'd say for all X, if X is a frog, fx, then AX, X is an amphibian. If I say students work at the library, I probably don't mean all students work at the library. I probably just mean something like some students work at the library. So I'd say there is an X where X is a student, SX, and WXL. So WXL means X works at the library, where the library, again, this is a the, where I'm talking about a particular place, lowercase l for the library. WXL means X works at the library. So there is an X, X is a student, and X works at the library. If I say employees are allowed in, this is pretty ambiguous, but you might tell from context that the person means only. So if it only, again, they're versus the direction. So only employees are allowed in means if you're allowed in, you must be an employee. So for all X, if AX, if you're allowed in, then EX, you're an employee. Very rarely we use the phrase all and only as a single phrase. So all and only, just like if and only if, can be translated with a two-way arrow. All and only bachelors are allowed in means for every value of X, X is a bachelor, if and only if X is allowed in. So we use a two-way arrow for that. We can take entire quantified statements and we can join them together just like we can join together simple statements in sentential logic. And we use the same connectives in the same way. So this is our review from Unit 1. If nothing is permanent, then nothing is illusory. You want to translate nothing is permanent as if it's a statement on its own. Then use an arrow and then translate everything is illusory as a statement on its own. So nothing is permanent means it's not true that there is something that's permanent. So not backwards EX, PX. The if then gives you the arrow. Then everything is illusory is for all X, IX. So those are two different quantifiers. Quantifiers just apply to narrow scope. They just apply to what comes immediately after them unless there are parentheses. So the backwards EX at the beginning doesn't apply to the IX at the end. No Republicans are environmentalists, but some Democrats are environmentalists. Again, you would just do no Republicans are environmentalists first, but becomes and then you would do some Democrats are environmentalists. So no Republicans are environmentalists, not there is an X, RX, and EX. It's not true that there is something that's both a Republican and an environmentalist. The but becomes the and in the middle. Then we say some Democrats are environmentalists. There is an X, X is a Democrat, and X is an environmentalist. If some students are confused, then all students are. So this is just a big if-then. We do the if part of the if-then. Some students are confused. There is an X, SX, and CX. Then we get the arrow from the if-then, and we say for all X, if X is a student, then X is confused. So it's if some students are confused, then all students are. It's not all students just are. It's all students are confused. That's what the person means. So we say for all X, if X is a student, then X is confused over in the right. If nothing is permanent and nothing is good, then all religions are fictional. So here we've got two things in the if part of the if-then joined together with and. Nothing is permanent. it's not true that there is an x is permanent, and nothing is good. It's not true there is an x is good. Arrow, for all x, if x is a religion, then x is fictional. Unless the host cooks or some local restaurant delivers, no partygoer will be happy. Unless is if not. So if it's not true that the host cooks. Now the host is a name of a particular person, so we just write CH for the host cooks. Some local restaurant delivers. There is an x is local, and x is a restaurant, and x delivers. If it's not true that either one of those, then no partygoer will be happy. No partygoer will be happy is, it's not true that there is an x is a partygoer, and x is happy. So I'm just going to do some more example translations just for practice, just so you can see how these work. No stolen merchandise is returnable. So it's not true that there is something which is stolen merchandise. It's stolen and it's merchandise, and it's returnable. You can also do that with a universal quantifier. When you use the backwards E, you almost always use an and in the middle. When you use the upside down A, you always use an arrow in the middle. So you do it like this. For everything, if it's stolen merchandise, then it's not returnable. There we go. Not all cheeseheads are drunk idiots. So when you have not before all, you put the not at the beginning of the statement rather than on the inside. So it's not true that all cheeseheads, CX, are drunk idiots, DX and IX. It's not true that everything that's a cheesehead is a drunk idiot. Some cheeseheads are excellent dancers. Now here we do have an adjective modifying a noun, but excellent dancers doesn't mean someone who is both excellent and a dancer. I'm excellent, I think, and a dancer, but I don't dance excellently. Excellent dancer means someone who dances excellently. So we're not going to treat excellent and dancer as two different predicates. We're just going to treat it as one predicate. So there is an x. X is a cheesehead, and x dances excellently. That's what the dx means. All local researchers are chemists or biologists. So for every value of x, if x is a local researcher, so x is local and x is a researcher, then either x is a chemist or x is a biologist. Some chemists and biologists dance. So here again, we don't want to say for all x, if x is a chemist and x is a biologist, then x dances. That would be talking about everyone who's both a chemist and a biologist. So we actually want to break this into two separate thoughts. One about chemists, for all x, if x is a chemist, then x dances. And, sorry, this is a sum statement. Some things that are chemists dance, and some things that are biologists dance. There is an x. X is a biologist, and x dances. So some chemists dance and some biologists dance. We want to break that up into two separate thoughts. We don't want to write CX and BX and DX, because that would mean you're a biochemist that dances. You're both a biologist and a chemist. That's not what this statement is saying. Only bats are flying at mammals. So again, for only, we're going to reverse the direction. For all x, if you're a flying mammal, if you're fly and you're a mammal, then you must be a bat. Only rabid dogs bite. So this is one of those sentence statements with only that's ambiguous, right? So only rabid dogs bite might mean the only dogs that bite are the rabid ones, or it might mean the only things that bite at all are rabid dogs. So if we're thinking about just about dogs, so the only dogs that bite are rabid ones, you want to say something like, for all x, if you're a dog and you bite, dx and bx, then you're rabid. But if it's about everything, you want to say the only things that bite at all. If you bite, you've got to be a rabid dog. Rx and dx. The only interesting courses are full. So again, the way I like to do the only is just that the same as all. If you're an interesting course, you must be full. So for all x, all interesting courses are full. For all x, if x is interesting and x is a course, then x is full. Everything is unique if nothing is synthetic. So here we've got two different quantifier words, everything and nothing. We've got two whole statements. We want to treat them separately. So everything is unique for all x, ux. That's the then part of the if-then. So we have if in the middle. You want to pull the if part out at the beginning. Nothing is synthetic, not ex, sx. Then everything is unique for all x, ux. Now this next one with angels, I had to write angels. Notice the A is lowercase. Because the A will turn into the upside down A, I can't actually do translations on the computer that use the letter A. So I'm going to use N for angels. Now there are angels just means EX, NX. Something is an angel. Angels exist. Only if becomes the arrow, not everything is physical. It's not true that for all X, X is physical. All species evolve unless no biologists are competent. So unless is not, if not. So if it's not true that no biologists are competent, now we have one not from the if not, the other one from no biologists are competent, then all species evolve. For all x, if x is a species, then x evolves. Everything is either mental or physical. So for all x, either x is mental or x is physical. Now I want to contrast 13 with 14. 14 says either everything is mental or everything is physical. Notice that everything occurs twice in 14. We don't want to translate 14 with just one quantifier. We want to do it with two quantifiers. You want to say either everything is mental, it's one thought, or everything is physical, it's a separate thought. If all numbers are finite, then every number is either even or odd. So first we'll do all numbers are finite. For all x, if x is a number, then x is finite. If that's all true, then for all x, if x is a number, then either x is even, vx for even, or x is odd. Again, I can't use e for even because e changes to the backwards e, so I'm using v for even. All right, so that's it for the second lecture. I know I'm going through this fairly quick, but you of course can always pause the video if you need to think about something some more. And do keep up with the homework. And I'll see you in lecture 3.